Hello everyone, we are group 5 of C division. Today our topic is virtual memory. In our group we have Bhushan Velikar, Madhur Bhutada, Piyush Bhutada, Radha Bhutada, Vaibhav Bhuvia and Srishti Bhuya. So what is virtual memory? It is a memory management approach that allows secondary memory to be utilized as if it were primary memory. It enables the computer to compensate for physical memory shortages by temporarily shifting data from random access memory, that is RAM, to the storage of disk. Then it is a typical approach used in computer operating system. Next slide. So what is the process? It is essentially a program that is being run. The execution must be in sequential manner.
What is paging? Paging involves breaking up the physical memory into smaller parts called pages and then mapping the logical memory addresses used by a program to these physical pages. This allows the operating system to load and unload pages of a program as needed, reducing the amount of memory required to run a program and improving overall system performance. So imagine you have a total of 8 subjects each semester. And because of the vast syllabus and time constraints, all 8 subjects cannot be taught in a single day. So to tackle this issue, the college or university carefully makes a timetable taking into consideration the number of lectures required to complete the syllabus on time. Assuming you have 4 lectures every day, you only carry the 4 respective subject books. Similarly, instead of loading one big program that occupies large amount of computer's memory, the program is broken down into smaller parts called pages. Each page is stored in its little folder in memory, and when the computer needs to use the part of the program, it only loads the page it needs. So paging allows the operating system to load and unload pages of a program as needed, reducing the amount of memory required to run a program. This is an example. This is the diagram. You can pause the video and take a look at it. What is page fault? Page fault is a type of exception or error that occurs when a program or process tries to access a page of memory that is not currently in physical RAM, that is random access memory. This can happen because the page has been swapped out to the disk or has never been loaded into RAM in the first place. What next? When a page fault occurs, the operating system needs to retrieve the missing page from the disk and load it into RAM before the program can continue executing. This process is called page swap or page in operation. If there is no available space in RAM, the operating system may need to swap out another page to make room for a new one. So the page that is not being used is removed and a new page that is required is added from the disk. Page faults can significantly impact the performance of a computer system as disk access is much slower than memory access.
Segmentation. Segmentation is a memory management technique used by operating systems to divide a program's memory space into smaller, independent units called segments. Each segment contains a specific type of data or code, such as programs, code segment, data segment, or stack segment. What are the advantages of segmentation? By using segmentation, the operating system can better manage the memory resources of a computer system. It can allocate memory for each segment separately and track the usage of each segment independently. This allows the operating system to allocate memory more efficiently and provide each program with the amount of memory it needs.
Difference between paging and segmentation. Paging, it divides memory into fixed size blocks called pages. Segmentation, it divides memory into independent segments of varying sizes. Paging, pages are usually 4 KB to 64 KB in size, while the segments can be different sizes based on the program needs. Paging, memory is managed in a linear fashion with each page numbered sequentially, while in segmentation, memory is managed in a non-linear fashion with each segment identified by a name or number. Paging. It requires a page table to map logical addresses to physical addresses, while segmentation requires a segment table to map logical addresses to physical addresses.
Segmentation with paging. Segmentation with paging is a memory management technique that combines the advantages of both segmentation and paging. In this technique, the program memory space is divided into segments of various sizes, and each segment is further divided into fixed size blocks called pages. This technique can be more complex to implement and manage than simple segmentation or paging. Internal fragmentation. Internal fragmentation is a type of wastage that occurs in a computer memory management when allocated memory space is not fully utilized. It occurs when a process or a program is allocated a block of memory that is larger than the amount it actually needs. As a result, there are unused memory blocks within the allocated memory space. Paging causes internal fragmentation.
External fragmentation. External fragmentation occurs when there is enough total memory available to satisfy a program's or process's memory allocation request, but the available free memory is not contiguous or not available in a single chunk. This can happen when small pieces of free memory are scattered throughout the memory space, making it difficult to find a large chunk of free memory to allocate to a memory or to allocate to a program or process. Segmentation causes external fragmentation.